Hello. In the previous video on projectile motion, I had ended the video with a question for you, and I had mentioned that you can refer to the solution that we just did for the previous question. Now, the question that I had left you with is that I'd drawn the diagram for that. We have two objects over here, and suppose they are set to they are acted upon by the same gravitational force, and one of the objects is projected horizontally along one direction while the other in the exactly opposite direction. The velocities in each case being the magnitude of the velocities, one of them being 3 meters per second while the other being 4 meters per second. This was the velocity, and they are obviously directed in the opposite direction. They are under the influence of gravity. They will take a parabolic trajectory as expected, and in that case what happens is that as they do so, there will be a point where they will be perpendicular to one another. So let's suppose this is the point where the first particle reaches with a speed 3, and it is here it has acquired some other speed. Let this one supposedly was v1, and this is a v2. Now if we take and this one probably is the point where this second particle reaches, and it is this one is v1 dash for the first object, and this is v2 dash probably for the second object. And when we consider the angle between them, if this is taken in the backward direction, this is further extended backward direction, the angle here comes out to be 90 degrees. So that was the question where we had left the projectile, and the particles will be making an angle at some point. uh, we were to find the position now, the position or the distance between these two points, where after reaching the particles make an angle of 90 degrees with respect to one another. Remember, they were initially left or projected at opposite directions over here, and now they have reached a point, or rather they have reached two different points. Initially they were at the same point over here, and now one of the particles is over here and the other one is over here, and the angle between them right now is 90 degrees that I have just pointed out over here. So that being the case, we want to determine the distance now that is there between them. So in order to find that, we may proceed as follows. I hope you must have tried. If you haven't, please, if you didn't get the hang of the question, please try and understand now. So we have v1 dash, that is the velocity that the first object acquires. We need not be concerned about the value of the velocities as of now. So v1 dash is simply equal to v1, that is the initial speed, v1 plus g times of t. G, obviously the acceleration acts in the downward direction. In a given time t, of course, it has reached over here, and at the same time the second particle has acquired a velocity v2, where its initial velocity was v2. The new velocity acquired is v2 dash. The initial velocity was v2, plus gt. We are using the first equation of motion, that is v is equal to u plus at. So u being the initial speed, in this case being v1 and v2 for the first and the second particle. Now the condition that we have at hand is that these two velocities, the final velocities after the time t, they are perpendicular to one another. So as simple as it sounds, it actually is that simple. So v1 dash dot product with v2 dash is going to be 0, because if they are perpendicular, then their dot products are going to be, or the dot product between them is going to end up with 0, because dot product is v1 dash into v2 dash cos 90, and you know cos 90 is 0, so that is why this value is definitely going to be 0, as v1 dash is perpendicular to v2 dash. Now with this available, what we can obtain, we will try and obtain the distance that was required. So with this we can use these values over here in this condition, that is v1 dash times of or multiply dot product with v2 dash is simply equal to 0, which is equal to v1 plus gt dot with v2 plus gt, that is the values of v1 dash and v2 dash. And with that done and dusted, what we can have is a v1 dot v2, then plus v1 dot g times of t plus v2 dot g times of t, and finally you have plus of g square t square. This is obviously a scalar quantity that we are having, because the dot products of two vector gives us a scalar quantity. So now consider, we have used the distributive property of dot products. Here v1 dot v2, that's fine, and this is fine as well. What about these two? v1 dot g, v2 dot g. Now if you remember, v1 here was acting along this direction, v1, that is the initial speed of the first particle, and g acts in the downward direction. So is the case with v2. v2 acts along this line, and g, obviously g vector, acts in the downward direction. So their dot product again involves cosine of 90, and that's going to end up with 0. So these two values will move, or will be discarded. They will be 0. What about v1 dot v2? v1 dot v2 is simply v1 v2 cos 180, because the angle between them is 180 degrees, because they were left in exactly opposite directions. So v1 dot v2 is simply v1 v2 cos 180 degrees. I'm writing this for you in case you do not understand. So this is v1 times of v2, and so with this thing available as well, what we get is that v1 dash dot v2 dash is simply equal to g square t square plus, or minus rather, v1 v2, and this obviously goes to 0 as per the condition given over here. So that implies g, g square t square is equal to v1 v2, or finally we have t to be equal to root over times of v1 v2 divided by g. Remember, time cannot be negative, so we discard the plus minus that was to come in case of the root over. We discarded the negative part and just stuck to the positive case. So this is the time taken, and from the time we can calculate this distance that was required to obtain. But obviously that is the relative position of the first with respect to the second, or second with respect to the first. And as we had discussed in the previous video, we had obtained a relation, that is R12 is equal to R012, that is the initial relative position, plus V012, that is the initial, V0 representing the initial velocity of 1 with respect to 2 multiplied with t, plus the relative acceleration, half of the relative acceleration times of t squared. Now, the relative position initially, because they were at the same point over here, that is over here, so R012 is definitely going to be 0. So this goes to 0. They are under the influence of the same acceleration in this case, that is the gravitational acceleration. So any form of relative acceleration between them is definitely going to be 0. So all that we are left with is a V012 times of t. Now V012 is simply V01, that is the velocity, initial velocity of the first particle, minus the initial velocity of the second particle. This is a vector relative case, so that multiplied with t. Now all we need to do is just obtain the value of this V01 and V02. Well, V01 is nothing but equal to V1, and V02 was nothing but equal to V2, right? So I'm writing it over here using the space over here. So because V01 is simply V1 and V02 is simply V2 in this case, and the relative velocity in their case was, because they are oppositely directed, so their velocities will get added. So that means a V01 minus V02 is simply equal to V1 minus V2, but that is vectorially. And what have we got in terms of magnitude? That is equal to V1 plus V2. Remember, in opposite direction, the relative cases, they just got added up directly. So finally this value, or we can say the R12 mod, just the magnitude of the position or the distance between them, s, that we had represented over there, s is equal to V1 plus V2 multiplied with t, that is equal to root over of V1 times of V2, the entire thing divided by g, because this was the value of t that we had obtained over here. So this is your expression for the relative position between them when they are at an angle, or they are making an angle of 90 degrees. They are normal to one another when projected horizontally initially in opposite directions after a time t under the influence of gravity. So that will be all for this edition of the video. Till next time, we'll be discussing a few more numericals. You can mail me any sort of numericals if you want to, that we can discuss on the various topics that we have been you know, making videos of. Till then, thank you for watching.